What is supervised learning?
Supervised learning is a type of machine learning where the model is trained on labeled data, providing examples of the input and desired output. The model learns the mapping between inputs and outputs.
What is unsupervised learning?
Unsupervised learning is a type of machine learning where the model is trained on unlabeled data without any example outputs. The model learns to find patterns and structure in the input data by itself.
What is reinforcement learning?
Reinforcement learning is a type of machine learning where the model interacts with an environment and learns to optimize actions to maximize a reward. The model isn't given examples, but must discover optimal behavior through trial and error.
What is deep learning?
Deep learning uses neural networks with multiple layers to create models that can learn hierarchical representations of data, allowing them to model complex patterns. Deep learning has enabled major advances in computer vision, speech recognition, and natural language processing.
What is transfer learning?
Transfer learning involves taking a pre-trained neural network model for one task and retraining it on a new related task. This allows you to leverage learned features from the first task and avoid training a large model from scratch.
What is data augmentation?
Data augmentation artificially generates new training data from existing data through transformations, increasing size and diversity of the dataset to reduce overfitting. Common augmentations for image data include cropping, flipping, and color jittering.
State one similarity and one difference between nearest neighbor algorithm and neural networks.
Similarity. Both nearest neighbor and neural networks are supervised learning algorithms used for classification and regression tasks. Difference. Nearest neighbor is a lazy learning algorithm that doesn't train a model, but classifies points based on distance to nearest neighbors. Neural networks train a model by learning weights and biases for neurons organized in layers to map inputs to outputs.
Why is mean square error accuracy measure more popular in machine learning than mean absolute error?
MSE's greater sensitivity to outliers, nicer math properties, and compatibility with neural network training make it more widely used than MAE in machine learning.
What is a hyperparameter? Give an example of 3 hyperparameters in neural network.
A hyperparameter is a parameter whose value is set before the learning process begins, rather than learned through training. Examples of 3 hyperparameters in neural networks: learning rate, number of hidden layers, batch size. Other common neural network hyperparameters include regularization rate, dropout rate, number of units per layer, optimization algorithm, etc. Properly setting these provides enough model capacity without overfitting. Hyperparameter tuning is key to maximizing neural network performance.
What is one similarity and one difference between validation and test datasets?
Similarity. Both validation and test datasets are used to evaluate machine learning models. Difference. The validation set is used during training to tune hyperparameters and select models, while the test set is used only once at the very end to get an unbiased evaluation of the final model. The validation set guides the modeling process, and the test set gives an impartial assessment of how the model generalizes.
Nearest neighbor algorithms suffer from the problem of curse of dimensionality. Can you state why?
The nearest neighbor algorithm suffers from the curse of dimensionality because the algorithm relies on computing distances between points in the feature space. As the number of dimensions or features grows, the relative distances between points start to converge, and it becomes harder to distinguish nearest neighbors. In summary, growing dimensionality makes proximity less meaningful, exacerbating the nearest neighbor algorithm's reliance on distance as the core similarity metric between data points. This causes it to break down with many features.
Why it is not a good idea to test accuracy on the training data.
Training accuracy rewards memorization rather than learning generalizable patterns. Relying on it can lead to overfit models that perform poorly on real data/new unseen data. It provides no independent assessment. Training accuracy is not measured on an independent set, so it does not provide an unbiased evaluation of the model. Validation and test accuracy on independent data better assess model performance.
What is overfitting and what is one approach that reduces overfitting in feed-forward neural nets?
Overfitting occurs when a machine learning model fits the training data too well, but fails to generalize to new data. One approach that helps reduce overfitting in feed-forward neural networks is dropout. Dropout is a regularization technique that reduces overfitting in neural networks by approximating training many distinct thinned networks, producing more robust learned features. This improves generalization performance on new data.
Why is ReLU more popular than sigmoid transfer function in modern neural networks?
ReLU enables more effective training of deep neural networks compared to the sigmoid activation function due to better gradient flow, non-saturation, sparsity, and biological realism. This drives its widespread adoption.
State one benefit and one drawback of using L1 regularization compared to L2 regularization.
L1 regularization induces sparsity, which can be beneficial for feature selection, interpretation, and reducing overfitting. But L2 regularization is mathematically easier to optimize with gradient-based methods due to its smooth squared penalty.
What is a support vector?
A support vector is a data point that lies closest to the decision boundary and has a direct bearing on the position and orientation of the boundary. Support vectors support and determine the optimal separating hyperplane in SVM.
Explain one issue arising when applying gradient descent algorithms on non-convex problems.
Gradient descent on non-convex problems can get stuck in local optima rather than reaching the global optimum.
What is the difference between batch and stochastic gradient algorithm?
Batch gradient uses the whole dataset per iteration, while stochastic uses subsets.
What is curse of dimensionality?
Curse of dimensionality refers to problems arising from too many features such as distance metrics becoming meaningless.
What is the rank of a matrix? Given a scatter plot with 10 positive and 10 negative examples, decide the class label of an unlabeled example in the scatter plot. The scatter plot would be provided for k nearest neighbor for k equals 1 and k equals 3.
For k equals 1, the unlabeled point will be assigned the class of the nearest neighbor. For k equals 3, it will be assigned the majority class among the 3 nearest neighbors.
Two of the features in the dataset used for regression are identical. What is the potential issue with using the closed-form solution for linear regression on such data? Propose one way to resolve it.
Identical features can make the XTX matrix singular and non-invertible. Remove one of the duplicate features.
What is exploding gradient?
If the gradients are large, the multiplication of these gradients will become huge over time. This results in the model being unable to learn, and its behavior becomes unstable. This problem is called the exploding gradient problem.